Hey everyone, today I'll be going over Leetcode 112, path sum. So you're given some tree and you have to find a root to leaf, so top to the very bottom path, such that adding up all the values equals some target sum. So the reason why this is easy is because it has to go root to leaf, so we don't have to do any like prefix sum or anything. You just kind of sum up from root to leaf, and if the sum at the end is equal to your target sum, then there you go, you found it, and then that's the answer to the problem. So if you look here, they're nice in the example. They highlight the path that actually adds up to the target sum, and you'll see that it's root to leaf. So root is simple. They give you the root. We already know the root. And then to determine what is a leaf in a tree, it is a node that has no child nodes. It is a bottommost leaf. So even though this one is 13 is higher than 2, it's still a leaf because it has no children. See, no left, no right. It's a leaf. So that's really it. That's a root and a leaf, and we traverse the whole tree and we find a path, and if it equals target sum, then that's it. So let's delete this definition right here and get right into it. So let's actually solve this two ways because this is like pretty easy to do. We can solve it recursively and iteratively, so you can decide which one you like. So what we can do is we can have a helper method. So let's go private boolean. Some people like to call it helper. I'm just going to call it has path sum. The reason why, because you can do this, what do they call it in Java? Like overloading or something. Can't even remember. But basically we can have target sum. And actually, now that I think about it, we don't even need a helper. Okay, to do this recursively, so they give us the target sum. So we can actually just add all the nodes, and if target sum is 0, it means we actually added up we can subtract the nodes from target sum, and if target sum is ever 0, it means we found the target sum. So we don't even need a helper. We do need a base case, however, and basically if root is ever null, we should return false. We shouldn't ever get here, and this is the case where we're at one of these nodes, like 4 here, and we try to go right. This isn't a leaf, so we shouldn't stop here, but also right is invalid. So this is kind of like our first little base case. Our second one we want to check for, now that we know that root isn't null, we want to check for if it's a leaf. So if objects is null, and you could do equals null, I don't know, this is just a little bit more clear. So if both root.right and root.left are null, that means that this is a leaf node. We want to check one more thing. So this is the case, so we know this is a leaf node. However, we want to check if we found the target sum. So if target sum is equal to 0. If target sum is equal to 0, then here we can return true. Okay, cool. But only in this case can we return true. And actually, to be honest, if it's a leaf, we're done searching here anyways. So instead of this, what we can do is we can just return, because we want it to be false if it's not target sum. So we'll just return target sum equals 0, right? Okay, so this is the first two base cases we got out of the way. Either it's like an invalid path, it's not a leaf or anything, and we should just stop, or it is a leaf, so let's check if we've accounted for all the target sums. Next, what we have to do is we have to, and actually, to be honest, before we do this, let's actually count this node to the target sum. So let's go target sum minus equal root.val. And even though it's minus equal, this is like adding. We're doing it in reverse because they give us the target sum and we're trying to reduce target sum to 0 so that all of those nodes actually add up to target sum. It's kind of a crafty way of doing this so that we don't have to find a helper method and we can just leverage this. Okay, so yeah, base case, do this, base case. Next, all we do here is we just check if we have a path sum in either the left or right subtree. So we can just go has path sum root.left target sum, or has path sum root.right target sum. We want to check both subtrees, right? And I run this, and I think that this is good, actually. Okay, that's good. And it's kind of like a clean recursive way to do it. I kind of like the way this does it. And to be clear about this, objects is null. You can just do your normal thing. A lot of people do this. I'm just used to writing it the other way because generally they use these as predicates like in Java streams and all of that. So yeah. Okay, anyways, enough rambling. Let's do it the fun way. So that was the recursive way. Let's try to do it the iterative way. To be honest, I don't even think I've done it this way. So let's try to figure it out. So I'm just going to, as I always do, since we kind of did like recursive DFS right there, let's do iterative DFS, which we use a stack for. And let's go stack of, so this is our stack for DFS, stack of tree nodes, stack equals new stack. And let's do this thing. Okay, so this is our stack, and let's see, can root ever be null? Yes, so we're gonna need a base case or an edge case or whatever you wanna call it. If this is null, root, we're just gonna immediately return false. Is it false or true? No, it's false because there's no nodes. So then what we can do, the reason why we take care of this is immediately in the stack, we can put the root. So let's do that. And then we can go as so long as the stack has nodes. However, we need a way to keep track of the target sum if we're doing it iteratively. And maybe there's other ways, I can't even think how to do this. So instead of adding just the tree node in the stack, and to be clear, just stop here if you like the recursive way. I'm gonna show you how I do this. So I'm gonna actually add a pair, which is going to, so we're gonna keep track of two things in this stack, the current node and the current sum. And that'll be in the form of a pair. Now pair, even though it says cannot find symbol, if we look at Leetcode, they actually include the pair class. This is something in a Java FX library. So a lot of people always use pairs. Think of this like a tuple in Python. It's just a way to add two objects at the same time. You can use an array or whatever you want to use. I don't really know. Then we add that, and instead of adding this, let's go new pair. And let's add both the root and the, let's think here, the root's value for the current sum. Okay, so that's all good. Let's go until the stack is empty. And then by the way, we should, in this, while we're DFSing through this stack, we should find a valid sum at some point. So if we ever make it out of this loop, we can just return false because we know we never found a valid path sum. So let's deconstruct the stack and let's go final pair tree node integer current equals stack.pop to pop the top. And let's also get these current node is equal to current dot, what is it? Get key, I think is how they do pairs. And then let's go final dot current sum is equal to current dot get value. Okay, so then now that we have this, all we have to do is check if the current sum is equal to target sum and current node is a leaf. So check leaf and target sum. So if objects is null, current node dot left, and then actually I did this wrong here. So if objects is null, current dot left, and we go like this, objects is null, current node dot right. If this is the case, then we want to also check if the current sum is equal to target sum. So if current sum is equal to target sum, then we can return true immediately because we found a leaf node in this tree. And we also found that its accumulative sum is equal to target sum. So then the key here is to, if we didn't, we know it's not a leaf, so we should add its children. So let's do that. And also we'll have to add the children's accumulative sum too. So if objects non-null, current node dot left. So first we'll add the left one here. Then we can go stack.add new pair, and let's go like that. And then we'll add the, how do you do this? The left, and then also the sum. So current sum, and yes, this way is much more complicated, and I'm probably doing it a silly way. But you know, it's the only iterative way I can think of at the moment. So let's do that. And then we'll go like this. Current node dot left dot val. Okay, cool. So that's adding the left and the left sum. And then let's go and do the same to the right. Just same exact thing, just swapping out some things like such. And I think that this is pretty good. And let's kind of like just indent these down to make it slightly more readable. And then I think that this is good here. Yeah, this is actually going to work. So this is the iterative way as well. So hope you enjoyed. And it's a lot worse, it looks like.